Let's go to the image enhancement when it comes to raster. So on this case, I am going to use the Landsat. So you are going to use your own Landsat, the one you downloaded to do land use land cover classification. So for the sake of indices calculation, I'm going to add all the Landsat band. So I'm going to add band 1, band 2, band 3, band 4, band 5, band 6, band 7, band 8, band 9, band 10, band 11. So all the band you have here, I'm going to add them. So in this order, so I'm going to add all the band. So don't worry about where I am, because the location of the data is not Nigeria, but you are still going to use the same thing of your choice. Like the same way you use your own, use the same thing I'm using based on the location you are. But what I'm saying is that this particular location is not Nigeria, so you are going to use what you have. Is that okay? So now today we are talking about enhancements. We are going to be using, when you get here, when you add all the band, you can choose not to add it, but I just want to add it like this so that we could be on the same shoe. So I am going to be using here. I might not use all of them, so I'm probably going to use, I don't want to clip for the sake of time and rest of them. So I'm not going to clip, but I'm going to go to the imagery here, window here. When you get to window, you will see this image analysis. This open the image analysis window working when you are working with imagery. So here for you, if you click on it, it will open. For me, I've already opened it. Is by the left hand side here for me here. So once you open the image analysis, you will see here, you can see the same imagery here. The same imagery that I added, all of them have been arranged here. And if you go up like this, you can see all of them are checked. Each of the imagery are checked. And if you open up here, you can see the band 1, band 2, band 3, band 4, band 9, band 10, band 11. So you can see all of them here. So what do we mean by image? So if you click on any of the image here, you can see this has been activated. If none of those are clicked, you can see it is not activated. So we are going to be doing a few things here. I want you to take critical note of this. Now the first thing I'm going to remember, when we're doing band composite, so we went to raster here. You remember we went to raster management here, and we went here to raster, and when we get to the raster here, we went to raster processing, and we go to band composite. Remember this? So we're able to do image composite, where we use our land use land class classification. But in today's, I'm going to use image analysis. And here in image analysis, you remember that we're supposed to use band 4, band 3, band 2. Now in this order, you see that this order is not arranged in a perfect format. And if I want to arrange it in perfect format, I will have to come to the table of contents to arrange them. So that means I need to return the table of content here, where we have band 3. So you can see here band 3 here, band 4, you can see it here. So if I rearrange it like this order, so that means I need to drag for on top of this and just like that. But I want to leave it by default, because your own might come in default. So to get that done, so you go to image analysis here, and you see band 4, band 3, band 2. I hold shift and select 3 of them. Remember image composite, so this will be activated. When you click here, you see here this is mask. So you use this to clip imagery. This is what we call here, if you hover over this processing here, it will be here. You will see the processing here. This is clip. And if you move over, this is mask. This is image band composite. So if I click on the band composite, it will automatically make that band composite for me. You see, I select 432. Remember that 432 is the color combination of natural color that we need to have. You remember what we did many times ago when we talk about band composite. So that's exactly what we're going to do, the same thing now. So if you select the imagery here, you can see that GIS Joes here, we say something like I think this is it. So we talked about band combination, so which you can always go to internet and type band combination of Landsat 8. So I'm using Landsat 8. So this is what I used last time. So when you go here, so you see that we are using 432, so which is going to give us natural color. So I am in 432 here, which is natural color. So if you look here, you will see that this is a natural color, but because of the band arrangement, that's why it is not showing naturally. So here, remember the first band according to the arrangement here is 2. So I need to change this 2 to 4. So the last one here, these have been changed. The second band here is 3, which is correct, because the second one is 3, which is correct. The third one here, as you can see here, is supposed to be what? Instead of this, is going to be 1. So once I select that, this is going to give me a natural color. So you see here now that I'm having a purely natural color up here. So you can see this is a pure natural color. So this is a way you can use image analysis to do band composite. Instead of you going into your PC to start going into here to look for it, this is the fastest way to get it done. Now we are talking about image enhancement. Now if you look at this, I have done this, the first one, which is composite. Now what are the different enhancements we are going to talk about? So in the enhancement, we use this to make different image enhancement, which is what I'm going to discuss with you right now. So in the enhancement, we have different tools we can stretch here. Here you can actually adjust the display, how it looks and the rest of them, so you can make an adjustment there. Now here we have where you need to darken here, we have constraint here, we have this is the brightness. If you want to do the brightness, this is the way you can also stretch. This is the way you can also, this is what you can use to stretch. Now here, this is gamma. As you can see, this is also gamma. Here is DRA, which is dynamic range adjustment. So with this, you enhance the constraint and the brightness automatically for better and clarity. Here is the background, to set the background or transparency of area without data. So any place, anytime you turn on this, any place that does not have color is going to, the transparency going to be seen. Then this one you are seeing here is resampling. So we use this resampling now here to do resampling to change the size of the data. So in my case, I want us to pick few things that are important to us. The first thing you can see here is that first and foremost, I click on composite here and I selected background. So this is going, any place that there is no data is going to remove the background. Here is top up. So there is nothing you see that take effect here, but I'm going to use DRA, which, like I told you us earlier, that DRA is dynamic range adjustment. So if you click on it, you see something that the imagery, bring it a close, look at the imagery right now. Let me turn it off. You can see the color. If you look at the color, you see practically different things from what I'm saying. So if you look here, if I click on the adjustment, you can see here that the color has been adjusted to what it is. So perfectly, this is a way you can adjust the color of the image. So even if you look here now, you see here that the built up area is well seen. If I turn it off, you should be able to see that it is a bit not clear. So this is a way you can make your adjustment. So if you click on it, then you can see now that this have improved. This is top up. You can see this is background to remove the background color. So but as we can see, you can also stretch the gamma. So if you look, I put it to this end, look at the imagery, then I put it to the right end, look at the imagery here. You can see if I double click on it, I will reset it. Now this here, as you hover over it, you can see the name. So if I drag it to the right, you can also see the effect on the imagery. If I drag it to this other place, to the left hand side, you can also see the effect on the imagery. So you double click and then it return back to normal. So you see this is where you can also adjust the constraint, so you can see the color it is now. Now this shows you where this, so if I click on this, that's going to return back to normal. The same thing that happened to this, you can also adjust the imagery here. As you can see, if I double click on it, that's going to return it to normal. But the most important thing, like I said, if you look at this imagery now, how dark it is, and you look at this now, you see that this is actually better. Another thing I want to talk about is the percentage rise here. Now these are different. You put it on none, the image return back to this as normally, as you can see here. You can see how the colorful the whole this thing is. Now, but if I now say this is this is minimum, then if I go down to standard deviation, this is what standard deviation gives us. Now if I go down to histogram equation, this is what histogram equation gives us. If I go down to percentage clip, this is what percentage clip gives us. If you go down to S-ray, this is what S-ray gives us. So at every point in time, you can see the impact of enhancing this. So if you look at this, it is a bit noisy, not just totally noisy, it's a bit cloudy. You can see here there is atmospheric dust on it. So with this, like this, you should be able to refine your imagery to look better than what it is. So you're able to see features you want to work on. So now if I click on standard deviation and leave it by default, you can see now this is what we have here. on the imagery. So this is a way you can make enhancement on your imagery, and that is going to perfectly get done for you. So this is the simplest and the perfect way of getting this done when you come to enhancing your imagery. Now there are some other tools here which we might not need, like this one I've said is mask, this is clip, this is NDVI. But if you want to do a bad composite, the moment you select the image you want to do a composite, you see this will be activated. This is mosaicing, so if you have issue to do with mosaicing, that's also going to be done for you. Now on a quick one, like we talk about NDVI. In NDVI, because I'm done with the image enhancement a bit for now, so this is what you need to do. You have any question on this? If you don't have question, I think I can proceed, because like I said, this is just a short place where we just need to talk about image enhancement. But if you look at what I did, you will see the impact of what I did, because if I click on this and turn off this, you will see that that is a bit dusty, and if I click on this and turn on this, you see it is better, and you can take this to stretch this to make it look better than what you want, or take this back to make it look better than what you want. So it depends on you. This is gamma. You can also stretch the gamma to the right or to the left by clicking on this. So this is just like a simple way of getting in your image analysis. So if you want to reset it, just click here. That's going to reset everything to 0 to what it is by default. But with this, like I said, you should be able to see that, oh, like the place you are looking here now, if I turn this DRA off, you see the way it is cloudy. If I turn it on, it looks better, so you can see, oh, this is a wetland, this is a water body, this is a water body, this is this. So you can actually make a kind of analysis, or have a good visualization on the imagery. So this is image enhancement. So now I am proceeding to NDVI, that is indices, spectral indices. Now here there is an indices here which we use to do NDVI. So this particular one you see here that have a 3 icon here. So we can use this particular one to get that done. Now in this case, we remember that NDVI we use the near infrared and red to calculate it in Landsat data. So what you need to do is, for example, we need to use 5 and 4 to get that done. So if you select both 5 and 4, and you can see that this particular NDVI icon have been activated here. So NDVI is used to compute the NVI. So if I click on it, this is going to go in and compute the NDVI for me. So if you look here, automatically I have the NDVI of this particular image that I did here. So if you look here, water body is off here, but the difference when it comes to the NDVI here is if you go to the table of content, you will see something different, but this gives you the NDVI of the entire area. So this is what it looks like, NDVI. But now let me explain a bit. Let me go to the table of content and talk about let me go to the table of content and talk about it a bit. So I am going to collapse this. Then you can see in the table of contents here that NDVI here value is showing us from 1 to a very long number to 255. Now this is not a value that they beat NDVI, because NDVI is supposed to be from -1 to 1. That is -1 to 1, which negative means no negative means bare soil, water body, rocks, and then with where you have make it down to 0, bare soil. Then from 0 to above to 1 means how the vegetation is. But if you look at in our own case, you see here that it is not in that manner. So what are we going to do in this case? So we need to make it calculate the right thing, or the way it's supposed to be. So if you look here, see now this is showing us NDVI, but that's not the right color. The value is really high. Now for us to get this thing done, so I'm going for you to calculate the NDVI. So I'm going to remove this because this is not necessary as at what I explained right now. Now I'm going here to NDVI here for me to calculate the NDVI. So first and foremost, I want you to understand what I mean by NDVI. Now I'm going to go into the website now. So if you look at NDVI, which we have been talking about, so you see that the vegetation index leverage on the property of red, which the vegetation absorb, and then the near infrared, which the vegetation strongly reflect, which as the name implies, we use it to monitor vegetation health and vigor. So NDVI ranges from -1 to 1. Negative value are indicative of water and moisture, but the high NDVI range suggests that the dense vegetation canopies. So we will be using this here. Now these are the list of the spectral indices for Sentinel and Landsat. So here you will actually see that the spectral resolution are not the same thing for NDVI for Landsat and Sentinel. They might not be matching. That is the reason why you need to know, if you are using Sentinel data, which of the NDVI, which of the band are you using for the computation. For a practical example is here. Here in NDVI, to calculate the NDVI for Sentinel 8, you use band 5 and band 4. Band 5 and band 4. In NDVI, in Landsat 4 to 7, you use band 4, band 3, band 4, band 3. In NDVI in Sentinel 2, you use band 8 and band 4, band 8 and band 4. So what I'm saying that you need to know the band that you ought to use at any point in time to make your calculation. So now in this case we are using Landsat 8, as you can see here. This is Landsat 8 LC08, which is Landsat 8. So that means we are going to make a kind of NDVI computation that is matching with this instead of this or this. So if I'm using Sentinel, I should be using this. But now I am using Landsat 8, so I have to conform with this formula. Now remember what we did in our last section in ArcGIS, where we have to do raster calculator. So we are going to repeat the same thing in this way to calculate the NDVI. Now to calculate the NDVI, I am going to go straight to the raster calculator. Now in raster calculator, so I have to go here, here, which is Arc toolbox here. Then when I get to Arc toolbox, you remember you move down to spatial analyst tools here. When you go to spatial analyst tools here, you go to map algebra. When you get to map algebra, you will see raster calculator. So if I double click on the raster calculator, this is going to come out. And once this come out, so what I need to do is, I already know what is those bands, like the formula for NDVI. Now in NDVI, like we say, I will return back. You don't need to cram it, you just need to know what do you need to calculate the NDVI. So now I am going to read this a bit to get you understand what I'm saying, because the NDVI is a numerical indicator that uses the red and near infrared band. NDVI is highly associated with vegetation content. Higher NDVI value correspond to area that reflect more in the near infrared spectrum. Higher reflectance in near infrared correspond to the dense and healthier vegetation. So now with this, like I said, you can see what we call NDVI and where we have, and like we said, it ranges from -1 to 1. Now for us to know where you are doing monitoring, this can be used when you are monitoring the healthiness of the environment. This can also be used when you're doing forest deforestation. This also can be used to monitor land use changes, like as the urban is increasing, is the vegetation around the place, is it decreasing, is it improving or not improving. Now like I said, you don't need to care about it, you just need to know that this is what you need to do here. Now I will return back here where I have this imagery. I can select it here. You see here, I've added it here. It is here. Now for me to calculate the NDVI of the whole imagery, what am I going to do? I'm going to go here. I'm going to use float. Now why do we use float? Float is actually what we use in many cases, because a float actually convert integer raster to float point raster. So in that way, the reason why we use it is because in decimal calculation, float point number allow for decimal calculation, which is essential and very good for spatial analysis, and then when it comes to modeling tasks. So you can use float also for precise, that is float, ensure that the calculation you perform are in sufficient precision, so reducing those reducing the rounding errors, and also it helps in division operation, where you perform a division operation, so it helps you avoid integer. So what I mean, instead of it truncating it, it is going to bring it down to the point. What I mean is, for example, like I said, the NDVI ranges from -1, 0, and 1. So if you did not use float, what it means is that you are going to have only the value that is either -1, 0, or 1, because that's an integer. But if you have float, if you calculate in float, you are going to have -0.2 or 0.3. For example, if you have a value that is, if you make a calculation and you have 1.0 and then 1.1137 is more precise. So what I mean is that when you are calculating this kind of a thing, so you need to use float. For me here, when I go ahead and click on float here, now from the formula we have here, it says that the NDVI for Landsat 8 is band 5 minus band 4. So I will return back to ArcGIS and select band 5 here. So I'm look for band 5 here and double click on band 5. Remember to double click. Now what is the formula for it again is -4. You click minus here, you see the minus appearing here. What is for band 4? You can see band 4 here. Double click on it. Now once this is done, return your arrow here, like this cursor that is moving here, and click on over. And then again return to float, the same thing. Now what is the formula again? It is band 5 plus band 4. So I will return back to this place and then click on float again and double click on band 5 here, and then plus, you look for plus here, and then plus band 4, you double click on it. So now this is the formula for NDVI, which we have inputted here. Once you are done, click on this. So you should be able to see here that the raster, so I'm going to write this NDVI. So I'm just going to write NDVI. I can't remember the year, but this is in 2025 over this place. So I'm going to just put NDVI 2025 here as the name. So I want to put it up here. Now this is the formula for calculating NDVI. Once I get here, the next thing I need to do is to click OK. So once I click OK, then I'll wait for it to finish computing. So you see here it is telling me raster calculation successful, but I didn't see the NDVI coming. So what happened? Current calculation. So let me quickly check to see what happened. The NDVI, and I'm going to add it to display. So that did not come up. Okay, so let me try again for the second time. I wonder why it did not show up, but let me check what happened. So we return back again. So you need to click on float, then go to band 5. So this is band 5 minus band 4. You return here and you say all over. You click on float again. So where is float? Double click, and then band 5, double click, plus band 4. So here, now this is here, so I'm just going to leave this by default like this, and I'm going to click OK. So this is supposed to bring me NDVI, so I don't know why it is failing. So I think there should be an issue. So quickly let me save the document first. All right. So now we are talking about spectral indices. So I just want to save it a bit, and then I'm going to remove it and I'm going to start up again. So I don't know what happens, why it is not. We are going to be talking about some of them. So I think my ArcGIS is up, so I wait for it to a bit to come up. then I will try repeating to see what is the problem. Okay, so I'm going to return back to here. So to calculate the NDVI, so I'm going to go in here. Then I already have these bands, this satellite data here saved. So what I need to do is to click on the app toolbox. So when I click on the app toolbox, that's going to open the app toolbox for me. So I will go to the spatial analysis tools, and under spatial analysis tools I will go to the map algebra, and then under map algebra I will go to raster calculator. So once I get there, I should be able to get to here. So you go from here, go to spatial analysis to map algebra, and then go to raster calculator. So once this is done, like I said, you pick up here the float. I've explained what float, why I am using float. So you go to the float, you put N5, which is band 5, minus this is band 4. I'll double click on it. I'll click here, all over here, and I'll click on float again, and then I'll click on band 5, then plus, then also band 4. Then when you click here, you should be able to see the location where the raster is supposed to be outputted. So once that comes up here, so I'm going to leave it in the default geodatabase. So it's going to be in the default geodatabase here. So for me, all I need to do is to click OK, and that's going to run for me and then calculate the NDVI for me. So you can see the raster calculator. So I think it had issues then. So once that comes in, you will see the difference between the other one, the NDVI that was having 255 and 0, and this one is going must be in the range of -1 to 1. That it must fall within this particular range. So now with this, you should be able to see what is NDVI. So you can see here now the NDVI is trying to tell us that it is 0.5 to this. So now in this case, I'm going to click on a new list and then talk about NDVI value explanation. So now what do I mean? So you see here now, you see this is just trying to tell you here, trying to explain to you, which I have explained to us. So negative values are mainly formed from cloud, water body, snow. Values close to 0 are primarily formed by rock and bare soil, and then the one that are close. So NDVI is used for precision agriculture in kinds of library. So you can actually say here the use of NDVI. So you can see what do you, or how do you use the application or the use of NDVI. So you can see the application of NDVI. So this you will have a better understanding of where can you use NDVI. So you can see here you use it for quantification. So there are different ways or different areas you can use NDVI. So I'm going to type the application of NDVI. So you will see different places you can use it for. I don't want us to go into this particular website. So here, let's look at this. So in NDVI is used for monitoring crop health, yield estimation and dictating plant stress. Also, NDVI is also used for assessing deforestation, like I said earlier, and then biomass estimation. NDVI is used in differentiating between vegetation, water, and urban area. NDVI is used in dictating drought affecting region based on the vegetation changes. NDVI is used in irrigation management, identifying area that may require more or less irrigation. Now this can be used in NDVI. So as you can see here, so if you look at this particular drawing, as you see, it tends to explain to us what to do, what is NDVI and how was it used in this context. So with this, you can use that to understand what changes that is happening. Is the crop stress or not stress? Is there a need for like if you look at this is not opening well, but I think this is perfect now. So if you look at this color, this is telling that the NDVI is 0.5. You can see the color here. This is NDVI of 0.3. This is what it looks like. This is NDVI of 0.38. This is what it looks here. This is 0.51. These have more healthiness. So you can see the color here has more healthiness. Now let's return back to ArcMap. When you look at this is the NDVI you have here. So what we need here, it is between 0.5 to -2, meaning that if I change this now to, let's put this color here, red and white. So if you click here, you can see where there is red is an urban area, water body, but where there is green is where there's healthy vegetation. Let's zoom close to it to explain this a bit. Now if you look at our data or the data set we have here, we have red, mean very low. Like I said, it is in negative, water body. So I'm going to go to analyst tools here, and I'm going to click on this one, and I'm going to click on the swipe tools here. So if I swipe across it, you should be able to see what I'm saying. Look here, that's water body. These places you see red are water body. Now where you see green are where the vegetation is very healthy. You can see here, you can see here the cloud, you can see the cloud, you see the color, you see. Let's go to the built up area, because we can see different built up area here. Now if you zoom close to here, what happens here, because there is a built up area here, so I'm going to swipe across, you can see the building there. Now this is a way you can monitor this particular NDVI, using NDVI to monitor this. So now I see here, oh, this is very healthy, this is not, this is unhealthy, this is stress, now this is healthy. So if you look at this thing that draw over here, if you zoom close it on it, it is water body. So if you swipe across, you can see it is a stream. You can see it is a stream. So NDVI, like I explained, is very perfect for us to do a lot of environmental monitoring and modeling. So if you look here, this is cloud. Now if you look here, you can see this place have a healthy vegetation. So this is a way you can monitor a healthy, where there is healthy vegetation or not healthy vegetation. Look here, this is an airport. So in airport, it is not healthy, because, so if you zoom and swipe across this here, you can see the airport. You see here, you can see how it is. But near the airport, there are places we have healthy vegetation, like here. Now if you zoom close to that particular place, to use this swiping tool now to swipe across it, you should be able to see that there is a vegetation there. Now also in identification here, by clicking here, you can click here to identify that particular point. You can see that the value there is 0.7. So you can see here 0.75. Now if you click on this red place, what is the value? 0.2, meaning it is here. So you look at where there is red, let's click on the red, you see minus 0.6, meaning that that particular area is not okay, like it is water body. So look here, that we have very healthy vegetation. Click on it, what happens? You have 0.44. Now what do I mean? If you want to do crop these estimations, you can have a random point, like a scatter point here, and able to extract the values of this location to it. So and be able to use that to plot a kind of able to use that to make a kind of plot. Remember, based on our training materials here, after this we're supposed to do something. We are going to do a kind of hands-on practicals. So in this, I'm going to put you on a rigorous format where I will want you to make a kind of plot. You are going to combine both practical knowledge of ArcGIS and as well as a practical knowledge of GIS, and of Python, to get to do this. What I'm saying is this: I want you to make a kind of creating, because you are not only using this aspect of, I want you to be able to be integrating a different kind of data, where you will use the GIS data and as well as integrate it with a data of Python to make your visualization or explain whatever you want to explain to your audience. And that is exactly where I want you to be. So what I'm saying is that, assuming you are doing this kind of work and then you are trying to let people know that there have been a changes over this place over these years, and then because of that you are saying that there is increase in urban, or there is increase in the stress of forest. Like I said, if you look here, you see here that I mentioned something like, when I open up here, different things you can use NDVI to do. So it is, both of us saw it here. So this, you can use NDVI to monitor them. So I want you to make a kind of visualization, like plotting this kind of thing, trying to show us with Python that This is a real life example of where you can use this type of data, and this is a kind of visualization you can do on these places because you want to make a kind of monitoring. So I will want you to have all these things in mind. Like I said, if you click here, you see the value here is 0.003. If you click here, you also see the value is 0.7. If you click here, you can also see the value is 0.3. If you also click here, you see the 0.4. So if you have a scattered point of about 10 points within here, you can make analysis that says that in 2020 the value for the NDVI is 0.4, but in 2021 it is now 0.3, meaning that there is decrease as related to the healthy vegetation there. So this is a practical way you can use NDVI to make monitoring. So you can see here the healthiness of the environment. By me looking at this, I will say, oh, this particular section is healthy, this is not healthy. And true, if you look at this place, it is an urban area. How do I know it's urban area? By the NDVI it reflected. Can I confirm whether it's an urban area? Yes, because once you click on the swipe and swipe across here, you must see this place as a kind of place that does not have, you see now, this is an urban area, it does not have vegetation. So how do you also know another urban area? If you look at this, look here, there should be urban, this place should be an urban area like here. Because why? Because of the vegetation density is not as much as this part of the area. So this is a way you can make different kind of monitoring. Now on a quick one, we can also do something like NDMI, which is Normalized Difference Moisture Index. So let me return back to this place I am, and then let's look for this. So we have green normalized vegetation, no, enhanced EVI. This is better because this does not have this have more power, penetrating power than NDVI, because this one does not have atmospheric issues. So this is EVI. This is advanced vegetation index here. This is soil adjusted vegetation index. This is used where in the area to know where vegetation cover is low. So this is survey. I believe you have been hearing about these things. This is NDMI, which is used in determining vegetation water content. It is calculated as the ratio between near infrared and that is short wave infrared values of the traditional fusion. So this is used in what? It is used in moisture index. Now here we also have moisture stress. To calculate the moisture index here, we remember the formula. Near infrared in Landsat it is band 5 minus band 6, band 5 plus band 6. So we return back the same way, go to data calculation and open up here, and then what do we need? We return back again to the float where we use the float. So I will look for floats and click on it. Now what do we use? From what we see here, say band 5 minus band 6. So I will look for band 5 here, and then say band 5 minus band 6 here, all over. We go to float again and we say band 5, we double click band 5 plus, we now plus, and then band 6, we double click on it again. You can see here float raster. So now what do we need to determine from what I see? So we are going to be determining the vegetation water content. So I'm going to copy this as well, and I'm going to go to this particular place. So I'm going to go in here and I'm going to copy this, and I say NDMI application, so that we can also see the application where that can be used. So now in this case, it says that it is used in vegetation. It can also be used for regular monitoring of water content in the crop. Determine feed farm zone with water stress. Improve tree harvest logistic planning. Determine consolidability in the fire-prone area. NDMI uses near infrared. So this is example, like what I'm saying, this is where you can use it. So you can use this in real life application, like as you can see here. So there are different other places you can use it. Like if you go and read more on the internet, you should be able to see different places you can use this. but you should understand this and know where do you need to use it, assuming the kind of research you're doing, in what application do you need to use it. Now if you look at this now, you can see here that the value for the NDVI is not the same value for the NDMI. So in that moisture, so let us also put it here and then change the color also to this and click apply. So you should see where we have that kind of moisture. So you see here, so you can see here, where do you have more, based on what we see here, that is used to monitor moisture level in vegetation. In which of these areas have higher moisture content? So you can see here have more moisture content. The vegetation here have more moisture content than the vegetation around here. Why? If you zoom close here, for example, you should be able to see that this particular one, let me turn off this and so that I can swipe across. This particular one here, here, let me change it to this, and then this particular one here, as you can see now what happened, why is it that I have more moisture content than here? Even though here you can see here have a green vegetation, but here have more moisture content. And if you look here, this looks like an island, and that is why there is no much moisture content here. You can see this color here. So this is used to determine the moisture content in the vegetation. So as you can see here, you can make a correlation analysis between this one and the one under it. So it is not the same thing. So if you look here, you see that here, even though the tree is more healthy here, but the moisture content around here is better than the moisture content around here. So if you look here, see here, this is red in terms of moisture, but this here, it is green in terms of NDVI. So you can see the difference between both of them here. You can see here. So this is the way you determine here. Now what it means is that even though that here the vegetation here is more here, like if you look here, you see that the vegetation in this regard or this place have less water content compared to here, even though there is vegetation here under the NDVI. As you can see here, the NDVI shows us here that these places have vegetation, but here this one is saying that even though it have vegetation, but the vegetation is not compared, water content is not, these places here have more water content than the other. So by analogy or by reasoning, you can say, oh, this section have more water content compared to the other section here. So this is a perfect way you can make a computation using application on NDMI. So you can also use another index parameters here, like I showed us here. There are different other parameters we could use. We have the moisture stress, we have also the green coverage, we have the burn urban. This is one you use to understand, like forests, where like in Australia, where fire forests are served as man-made, or this, they are destroyed the natural life course on urban. It releases a huge of carbon, amount of green carbon here. You can see here NBRI takes advantage of near infrared and short wave, which is sensitive in vegetation changes, to detect the burn area and monitor the recovery of the ecosystem. So this is for this. Now we have for bare soil. This is used to actually monitor where you have isolated to the bare soil. Now this is NDWI. This is to monitor the water dynamics analysis. This index uses green and green near infrared of remote sensing imagery. This enhance for water efficiency in most cases. So now, what is the formula here? In Landsat it is B3 minus B5. So and B3 minus B5. So for us to do the same thing, we still return back the same way using the raster calculator and say B3 minus B5. So I'm going to go to float, and then I will say B3 here. So I'll look for 3. So I will say B3 here minus B5. Then all over, I'll return it here, and also say float again, and I say B3, double click on it, minus, I will say B5. So once this is done, I can actually have this and I will run it. Now while it is running, we can now go to the NDWI here to actually check for the application. So I'm going to this and paste this and copy it and say application. So in terms of application, so you can see here, we didn't have the perfect one that shows us the way the other one shows us, but this can actually be used in monitoring the dynamics of water body. So let's open up this to see this. So the NDVI here, this is how you calculate it. The application used to need to detect the water body, sharpen its outline of the map, and then monitor the changes in clarity. NDVI indices is applied beyond the visualization of the spectrum towards infrared. The water reflects no light. The NDVI makes use of properties. So these are places what is trying to explain to you where you can use NDWI. So in our case, it is still running. Yeah. So while it is still running, we can also go look for other places on the internet where we can apply NDWI. So you can use that to monitor the water dynamics or water changes. So this is, like I said, there are different things you can use these indices for, so which I'll be sharing with us. But like I said, you need to know, as an environmentalist who chooses satellite imagery for environmental monitoring, you need to know where do you need to use all these indices, so that you'll be able to use it perfectly and then use it for different application or different environmental monitoring. So this is actually showing us something wrong, because it is giving us low, 0 and low this way. This actually have a kind of issues. Yeah, so because I didn't get, you can see here I didn't get the right feedback, so all of them is between 0 and 0, so which ought not to be that way. So to make a pure cross check again, so we can try again and then be sure that we use the right thing. So this NDVI, so the NDWI uses band 3 minus band 5 and then band 3 plus band 5. So I think that's what I use. So let me just try it for the last time. So we start going again, because it has to be float. So I'll select the float, and then I will say here where I have band 3, so I have to look for band 3 and say band 3 minus band 5, and then all over float again, band 3 as well plus band 5, and this is here, and then we can run for the, we can now run for the NDWI. Alright, but remember, when you're calculating, know the imagery you're using. If you're using Landsat 8, you need to know the one we are using, because I know that even if you study under Software Chamaka, they keep on telling us NDVI, monitoring tree, monitoring precise agriculture. There are a lot of things to do with related to this. Like I said, this is a perfect example of where you can use it. So I think this I've calculated, but it is still, yeah, this is perfect. So you can see here, this is for water index, the water dynamics. So let me turn off all and also turn off all of them, so that we have the ones we need. So I'm going to put the composite and as well as the NDWI here. So I'm going to change it and put it in the same color. So now in this case, I'm going to put it in another color, so that we have different color brown. So now this is the water dynamics. So if you look here, this is trying to show you the area that have high water, like as you see here, the more water content. So if you see here, this is where the water is high, which is up to 0.1. Now look here, you can see here, sorry, bits. So you can see here that this have a kind of dynamic of water content here. So you see up here that these have more water content here. So this particular location have more water content than this particular location here. You can see here, these have more water content. See here, you can see the water body here. This is more shallow. These have more water body. This is more shallow. But from what we see, the places that have the color here, red, are places that does not at all, like look here, if you look, zoom close to a bit here, so you can see here, this center of the stream have water, but this other side of it is dry, like you can see here. So this is a way you can monitor the water dynamics. So with this, it extracted for me the places you can have water interaction. I can see get water. So if we zoom close to this particular place also, you can see here, you can see the water body, well masked and extracted. So you see here, these have less water content. You see here, these have more ground. So this is a way you can monitor a different location or different places that have water dynamics. So this is a perfect way of getting it done. So you see up here, so you see here there is a water body there. So if you zoom close now, you're able to see the water dynamics water body here. If you look here also, you can see here that there is a water body here, but now this green area which have more water content, and that's what you can see here. These have more water content. So this is a way you can monitor the water dynamics. So you can monitor that over the years, and then should be able to get this kind of thing done. Is that okay? Or yeah, the white things that are looking like that is cloud. This is a cloud. Yes. Yeah, so that is the reason why if you turn on those locations, it is also affecting it because it is a water content. Did you see the perfect example now? A cloud have a water content, and that is why it is within this range. You can see this range here. So this is why it is there. Yes. So but these other places that is ash means there is no water body. So you can look at water body. You can see boldly that there is a water body here. Is that okay? All right. Any other question?